In this video, we're going to take a look at how you would go about drawing the derivative when given the original function. I think the main thing that you need to think about is that the derivative is the slope of the tangent line. So if you can draw the tangent line at any point along the curve, then visualize that, figure out what the slope would be. Would it be negative? Would it be zero? Would it be positive? And then that's going to indicate to you where the derivative needs to be located. When the slope of the tangent line at any given point is positive, the derivative, the graph of the derivative, should be above the x-axis. When at any point along the curve you draw that tangent line and the slope is negative, then the derivative should be below the x-axis. And then obviously if we had a tangent line that was a horizontal line, the slope of the horizontal line would be 0, so it would need to be crossing the x-axis at that point. The graph of that derivative would need to cross at the x-axis at that point. So in this first example here, we're going to start with a very, very simple one. We're just going to go with a linear equation. All right, now the thing you have to know about linear equations, I mean, when you have a parabola over here and I ask you to draw the point, the tangent line at any given point along the curve, well, it's a curve, so it's real easy to draw that tangent line. Some people get really confused when you have a linear equation. At any point in time along that line, if I need to draw the tangent line, it's going to be the line itself. So when you have a linear equation at any point along that curve, if I'm trying to draw a tangent line, it turns out to be the line itself. So basically, I'm looking at the slope of this line. The derivative is the slope of this line because it's the slope of the tangent line. The tangent line is the line itself. Okay, so I can real easily look here. We got a rise of 3, run of 1, so I have a slope of 3 over 1. I have a slope of 3. So that means my derivative has to be 3. When I draw the graph of the derivative, it has to be 3 along the entire graph. The only way to accomplish that is to have a horizontal line. Okay, so this right here at 3 would be the derivative, a picture of the derivative of this original function. Okay, so now that's from a visual standpoint. Now, can we, because this equation is really, really simple, and we could make up an equation for that, okay, it's going to be f of x is equal to 3x. The slope of this line is 3. It goes through the origin. This is the equation of this line. So if I wanted to look at it from an algebraic standpoint, okay, can I take the derivative of that? I can. Derivative of 3x is going to be 3. So if I'm going to graph this, I'm basically graphing y equals 3, which is that horizontal line going through 3. So we can look at it and verify from an algebraic standpoint what we are doing pictorially or from a graph here. Now, that won't always be the case. Sometimes the original function that you're going to be looking at is going to be way more complicated than these two examples, in which case you're going to have to rely on your visual perception of this. Okay, now let's take a look at this graph right here. Okay, let's do it from just a graphical standpoint to begin with. We have an upside down parabola. Now what I want to do is I want to look at intervals along that x-axis. Okay, so, and kind of like, okay, wherever that tangent line is all doing the same thing. So over here on this part of my upside down parabola, if I draw tangent lines, if I draw a tangent line right there, I didn't really touch it there, but roughly right there. If I draw a tangent line over here, all right, all of these tangent lines from negative infinity to x equals 0, they're all the same way, in the sense that all their slopes are going to be positive. They're all going in the same direction. So from negative infinity all the way up to x equals 0, the slopes of the tangent line are all positive. Okay, so that means that when I go from negative infinity to 0, the graph of my derivative has to be above the x-axis. Okay, has to be above the x-axis. Now, before I actually start and put anything down over here, let's go ahead and take a look at this maximum point right here. At that maximum point on this parabola, my tangent line is horizontal. Okay, when my tangent line is horizontal there, then my slope equals 0. All right, so that means literally at x equals 0, my derivative has to go through x equals 0, because that's a very specific point along the curve. Now if I go from x equals 0 to positive infinity, if I look at this interval in my original graph, every one of these tangent lines over here, all right, no matter how I draw them over here, they are all going to have a negative slope. Okay, so then that means from x equals 0 to positive infinity, when I draw my derivative, I have to be below the x-axis. Okay, so above the x-axis, I've got to go through the origin and then below the x-axis. Okay, so this is going to be the graph of my derivative. All right, so you're analyzing those slopes of the tangent lines and do them in intervals wherever it's consistent. Like all of the tangent lines were this very similar over here. They all had a positive slope. From 0 to positive infinity, all the slopes of the tangent lines were negative. Okay, so you can break it up that way. Now again, if we want to go back to a more concrete algebraic approach, I can pretty much come up with an equation for this upside down parabola. Let's just say, obviously it's upside down parabola, so let's say maybe the equation of that original function is a negative 2x squared. All right, goes to the origin, negative coefficient, we know it's upside down. All right, not drawn to scale, so not worrying about how narrow or how thick it is. If I take the derivative, all right, then taking the derivative there, we'll have a negative 4x. All right, so again, think of that in terms of a linear equation. I'm going to have a y equals a negative 4x. Okay, so again, can I graph that line? Yes, it's a line that goes through 0, 0 and has a slope of negative 4. Okay, so just a sketch here, but definitely a negative slope. So again, if I go back to a more concrete method and looking at this algebraically, it then makes sense. Okay, so like I said, these are two very simple, examples that you would start at the very beginning of the process when you're learning how to draw the graph of the derivative. Once they get a little more complicated, you're totally going to have to rely on looking at these slopes of the tangent lines and then thinking, okay, should it be above the x-axis? Should it be below? What's happening? Where it's going to go? Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.